Hello again, welcome to another lesson in geometry. Today we are covering section 11-4, volumes of prisms and cylinders. So label each diagram as a cylinder or a prism. So we've talked about all these shapes before. So our first one is a cylinder. Okay, that's a circle on the top and bottom with a big old rectangle wrapped around it. Okay, the second one is also a cylinder. Okay, and then this one is a prism. It's a rectangular prism. And then our last one is also a prism, but this is a triangular prism. It's triangle tops and bottoms with rectangles all the way around. All right, vocabulary builder. Composite. Related words, compound, combination, and component. So definition, composite means put together with distinct parts. A main idea is a composite is a whole made up of different parts. So we'll start doing composite shapes soon where we put more than one shape together and ask you to find the volume. All right, so complete each statement with the correct phrase from the list below. Use each phrase only once. So number 5, a composite sketch combines different descriptions of features. So this is what you might do if you are a policeman sketch artist. So you try to describe all the features that somebody says for a suspect. Okay. A blank has factors other than 1 and a number, so this would be a composite number. Okay, it's made up of many prime numbers multiplied together. Okay. A blank shows a location of shopping malls, houses, and roads in one illustration. So this would be a composite map. So it doesn't just show streets, it shows all the things around it, okay? So a blank shows how to apply at least one function to another function. So this is a composite function. Okay, at the top we have Cavalieri's principle. So Cavalieri's principle says this: if two space figures have the same height and the same cross-sectional area at every level, then they'll have the same volume. So the 3 prisms below have the same height. That means they're all the same distance tall, and they have the same volume. The first is a square prism, so let's label the missing dimensions. So this is a square prism, so it's going to be 3 by 3. So a cross section here is going to have an area of 9 centimeters squared. Okay, so this second prism is a square prism, but it's oblique. Okay, but that's not going to change it because each cross section is going to still be a square, 3 by 3, so that it will have an area of 9 centimeters squared. Okay. And then in our last one, we have a triangular prism, but we know it's supposed to have the same volume. So since it has the same height, then the cross section should have the same area. So the area for a triangle is going to be base times height divided by 2, or 0.5 times base times height. So we know this is still supposed to have an area of 9 centimeters squared for a cross section. So this triangle had to have an area of 9, and that means that the base has to be 6 centimeters. So that can do 6 times 3 and then cut it in half and still get 9. All right, so circle the solid or solids that have the same cross-sectional area at every level. And this should be cylinders and prisms. So cones and pyramids, as we cut through them, here's a cone for instance, the bottom circle will be much bigger than this circle that's part way up, okay? All right, so the volume of a prism is the product of the area of a base and the height of the prism. So we only need to know the area of the bottom cross section, and then we can times it by how tall it is if it's a prism. Okay, so a prism with a base area of 15, that would be like saying that this cross section on the bottom is 15, and a height of 4, that would be like saying this distance from here to here is 4, will have a volume of 4 times 15, which is 60 meters cubed. Now volume is how many cubes could fit inside to fill up the shape. Remember, squares were how many, surface area was how many squares to cover the outside of our three-dimensional shape. Volume is how many cubes to fill the inside. So that's why we get meters cubed here instead of meters squared. All right, so a prism with a volume of 81 feet cubed and a height of 3 feet should have the area of what? So they're saying, hey, this is 3, but if I times it by that, I should get 81. So this needs to be 27 feet squared, because 3 times 27 will give us 81 feet cubed. All right, problem number 1, find the volume of this rectangular prism. So what is the volume of a rectangular prism at the right? Circle the measurements of the base of the prism. So the base of the prism is 5 by 3. That's the bottom cross section. So 3 by 5. Okay. Underline the correct words to complete the sentence. The base is a rectangle. It's not a square. It's 3 by 5. So the area of the base is going to be length times width here. We should start with a formula, which will be 5 by 3 for 15 feet squared. And then to find the volume, we're going to do the area of the base times the height of our prism. So in this case, our area was 15, and the height was 4. So 15 times 4 will give us 60 feet cubed. Underline the correct word to complete the sentence. The units for volume are cubic feet, okay, not square feet. We're not finding surface area anymore. So the volume of the prism is 60 feet cubed. All right, let's flip it over and take a look at page 3. All right, problem number 2, finding the volume of a triangular prism. So what is the volume of the triangular prism at the right? Okay, the base is a right triangle with legs of 6 and 10. Okay, so it's a triangular prism because it has 2 congruent parallel bases. In this case, it is a triangle, which is 6 by 10, and then it's got rectangles all the way around those 2 bases, so that's what makes it a prism. Okay, so the height of my prism is 5. Okay, that's the distance between the 2 triangle bases, so 5 here. So complete the formula for the volume of the prism. So the volume of the prism is large B times H, and that big B, remember, is the area of the base. So in this case, our base is a triangle. So the area formula for triangle is 1/2 base times height. So we're going to put in 6 and 10 in this for the base and height, which will give me 1/2 times 60 or 30. Okay. And then our volume is big B times H. So in place of big B, I'm going to put 30. And in place of H, I will put 5. So this will multiply to 150. So the volume of the triangular prism is 150 meters cubed. All right, theorem 11-7, volume of a cylinder. So the volume of a cylinder is the product of the area of the base and the height of the cylinder. It's just like a prism. It uses the exact same formula. Volume is equal to big B times H. Except our base is a circle. So we use the formula pi r squared in place of big B. So shade the base of the cylinder at the right, and I did. I shaded it blue, and describe what shape it is. This is a circle. All right. So in number 3, we're going to find the volume of this oblique cylinder. So remember from Cavalieri's principle, it doesn't matter that our cylinder is leaning over. We could just find the volume of one of the cross sections and then times it by how tall it is. So what is the volume of our cross section, or what is the volume of this oblique cylinder? So first we need to find the radius. So the diameter is 2, so our radius will be 1. And then we're going to use our formula V equals pi r squared H. Remember, this is really big V times H also. Okay. And then we're going to get pi times 1 squared. And then our height is 3. It's straight from the bottom at a right angle to the top. And you can see the right angle right here. So we're not using slant height for volume. We're using regular height. So this is a height of 3. Now we just simplify it. So 1 squared is 1, and 1 times 3 is 3. So our total volume is going to be 3 pi meters cubed. All right, let's flip it over and take a look at the last page. Okay, problem number 4, finding the volume of a composite figure. So what is the approximate volume of the lunchbox shown at the right? Round to the nearest cubic inch. All right, so this lunchbox is not a standard shape here. So what we have instead is a rectangular prism that makes the bottom of the lunchbox. And then we have half of a cylinder sitting on top of that for the lid of the lunchbox. So let's go ahead and break this into two shapes. So our first shape, one more time, is the top of the lunchbox here, which is going to be half of a cylinder. And that cylinder is going to have a height of 10 and a radius of 3. Okay, so our radius was drawn right here as 3. Okay, and then the bottom of the lunchbox is same 10 by 6 by 6. So that's that 10, that 6, and then the height of 6. All right, so we're going to find these two. So find the volume of the top. So it's normally big B times H, but since this cylinder is cut in half, we put 1/2, and then there's our big B, and there's our H. So pi r squared is the formula for the circle, which is our base. So we're going to put pi, and our radius was 3 squared. And then the height of this, the distance between the two circles, is 10. Even though it's laying on its edge, it's still 10 tall. All right, so we can work that out. 90 cut in half will give me 45 pi. All right, then we're going to find the volume of the bottom. That's length times width for our rectangular bottom, so 10 by 6 with a 6 as the height. So 36 times 10 will give me 360 for the volume of the rectangular bottom part of our lunchbox. So our whole volume is going to be the sum of these two together, which is 45 pi times 360. Now we're asked to find the nearest cubic inch, so we're going to type this in our calculator, which will give us 501.37166, keep on going. So we're going to round that to 501 cubic inches. All right, our lesson check. As always, pause the video, try your lesson check yourself, and then come back and go over it. Okay, and look for mistakes. All right, so our lesson check, welcome back. How is the volume of the rectangular prism with a base 2 by 3 and a height 4 related to the volume of a rectangular prism with a base 3 and 4 and a height 2? All right, explain. So cross out the formula that does not give the volume of a rectangular prism. So this is the standard starting formula for a volume of prisms and cylinders. This is what we change it into for a cylinder, and this is what we change it into for a rectangular prism. Okay, so we need the first and second, the middle one's bad. All right, so the commutative property of multiplication states that the product of factors in the same when listed in a different order. So even if I multiply 2, 3, and 4, or I do 4, 3, and 2, I'm still going to get the same answer because I can multiply in any order I want. So answer the question here. So the volumes are equal. Because we can use the commutative property to reorder the values to show they are identical. Okay, so for instance, if we did our first one, it would have been volume was 2 times 3 times 4. That's our base and height for the bottom, and then 4 is how tall it is. And the second one, the length and width for the bottom is 3 by 4, and then it's 2 tall. But we could just rearrange these to make them the same because we're multiplying the same 3 numbers in both. All right, so check off the vocabulary words that you understand. Volume shouldn't be new for you. And then composite space figure, just a different name for what you did before when you used to find volume of different shapes all stuck together. Okay, so hopefully you're in here. Found it a nice review from some Math 8 or Math 7 stuff you did on volume. If not, you'll want to watch the video again.